Let's imagine you have a large data set, and from that large data set, you want to randomly select a smaller proportion of data from that data set. This is what is called as random sampling, right? This is random sampling. But why is this useful? What are the different cases in which you would use random sampling? Let's imagine a scenario where you are building a machine learning model. You are going to build a machine learning model on a large data set. Now, typically, you wouldn't build or train your model on the entire dataset. What you would do is you will take a smaller sample of that dataset, run your various experiments on that smaller dataset. Once everything is tuned and set up, you will build your machine learning model on the entire dataset finally. Right? This is often used approach or technique when you are building machine learning models. So this is used while you are building machine learning models. Second use cases, there are certain machine learning algorithms such as random forest. It uses bootstrap sampling internally when it is actually training your model. This is another use case. Besides this, bootstrap sampling can be used to compute confidence intervals also. Right. Third one is random sampling is used during cross validation. That is, you have a data set. From this data set, you randomly sample a set of observations. Say this is a random sample, a randomly picked sample. You train your model on this data set, use the trained model and test its performance on another random sample of your original dataset. This is a technique called cross validation to validate the performance of your machine learning model. These are some of the use cases. Now, implementing random sampling in Python is very easy. You have a function called sample inside your data frame. Sample method of your data frame, you can use this to create your random samples. Let's implement this on property crimes dataset. Now the dataset looks something like this, where you have the area, year, group name, subgroup name. This is a type of crime. Under this type, there are various different categories within this subtype. Now here we have columns called property recovered, property stolen, value of the property required, value of the property stolen. Right? This is the data we have. From this, we want to select 70% of the observations in this dataset. So what we will do is we will compute what is that 70%. Get the total number of rows, multiply it by 0.7. You get the number of rows that you want to pick. This you pass it as an input to your sample method. By setting replace equal to false, it will ensure that the rows that are picked once will not be picked up again. Secondly, you also have a random state. This is for pseudo randomness. What it means is, say you are running this code once and you will get a sampling output. Right? You are getting a set of rows being sampled, right? Again, if you run this also, so you will get the same random set, the same 386, 2415, all these rows are picked up again. That is because we have set this random state to a fixed number. If I change this number to say, I'm going to change this to 101, a different set of random sample will be created. No matter how many times I run, as long as the random state is remaining the same set of random samples is going to be picked up. And this particular variable can take any value, it doesn't matter. It can be 0, it can be 1000, it can be 10,000, whatever number. As long as the number is the same, you are going to keep getting the same set of rows being picked up. All right. Now that is picking up random samples using replacement. Now what is bootstrap sampling? Bootstrap sampling is a special random sampling technique. Only one difference is, in bootstrap sampling, say you have 100 rows in your data set. A bootstrap sample, say this is 100 rows, right? A bootstrap sample will also have 100 rows, same number of rows. Only that when you are randomly picking the rows, you will allow the rows to be picked up again. That is, you will set replace equal to true. That's what we are doing here. Now, since by setting frac equal to 1, I'm going to select the same number of rows that are present in df, right? And set replace equal to true. The result of this is going to be what is called as the bootstrap sample. All right, so that's about sampling. Let's do a mini challenge on this one. So the challenge for this video is compute the 95% confidence interval for this particular input. You can get this code from this URL. And the procedure to calculate the confidence interval is listed down here. First, make bootstrap samples for 10,000 times. Take 10,000 bootstrap samples. Calculate the mean of each of these 10,000 samples. Then compute the 2.5th percentile and 97.5th percentile, which will form the lower and the upper bounds of your confidence intervals. If you have a computer nearby, try it out. Otherwise, here's the answer. the exact numbers that you will see on your screen can be different because we are using random number generation. Hope you got it right. If you did, congratulations.